Hello, my AP Calc scholars. I wanted to do this video for the solutions to our Unit 2 test. One, just because I like doing the math, and two, also because I think it helps to explain the solutions and not just post the solutions for you to see. All right, so on this first one, now some of these were meant for you to be able to do them in like 30 seconds or less. So this one right here, when we're talking about the average rate of change, we know the average rate of change, f of b minus f of a divided by b minus a. And I don't know why I'm going uphill here. All right, so it does not matter what our function is. The average rate of change is going to be this formula. So we can rule out everything else. And the only thing that matches this formula, if we have a is pi over 4 and b is 3 pi over 8, matches our answer choice C. All right. And this one here, we have the differentiable function f and the line tangent at x equals 2. So here's our tangent at x equals 2. And we want to know what is the value of f prime of 2. Well, we know f prime equals the slope of the tangent line. So that means f prime of 2, we want to know what is the slope of the tangent line at x equals 2. Well, the slope of the tangent line there, well, given the tangent line, we can find our slope from the graph. All right, let's get that to look a little better. There. All right, so what is the slope? What is the slope of that line? There, okay. We have a rise of 1, a run of 2. So that slope is 1/2. Okay, and now that I have my answer choices up here, that slope, again, that answer is 1/2. That tangent line has a slope of 1/2 at x equals 2. So that was another one that was designed to be done rather quickly. All right, we want the derivation of the derivative of cotangent x. And we're starting off with our trig identity, our reciprocal identity, that cotangent x, and I'll go ahead, the derivative of the cotangent x is equal to the derivative of 1 divided by tangent x. And we're putting into action here our quotient rule. So our quotient rule, see here, we've got f prime g minus fg prime divided by g squared. All right, just going off the way I learned it. I'm not even going to try to learn that little song they had. All right, so looking at this, we can go ahead and rule out A and B. That doesn't look anything like our quotient rule for A and B. And we've got f prime, so go ahead and write it this way or show it this way. That's f and that's g. So we're looking at f prime g. We want the derivative, and I'll just show it the way they're showing it. We want the derivative of 1. Actually, I don't have enough room. Times tangent x minus 1 times the derivative of tangent x divided by tangent x squared. All right, the derivative of 1 is 0. And looking at our formula, again, that matches C is what it matches because we have our minus and our g squared right here. And then back to, okay, so as I was saying, the derivative of 1 is 0, so that wipes out this term right here. And we're left with negative secant squared divided by tangent squared, answer choice C, as we've already got. Okay, keep it moving. Now we're looking at our product rule. But we want to make life simple for us. So let's look at simplifying this expression. We've got cosine x times sine x divided by cosine x. Always look to see if we can simplify before we make life too difficult for us. And that equals the derivative of sine x, which is cosine x. Our answer choice B. All right, now we're looking at a polynomial, so we're going to put into effect our power rule. F prime of x. Let's see if I can write this without going uphill or downhill. We've got 15x squared minus 3. And we see there is no calculator symbol on here, so this is meant to be done without a calculator. Giving us f prime of 2, negative 2, is going to equal 15 times negative 2 squared minus 3. That's 15 times 4 minus 3. 60 minus 3 equals 57. All right, now on number 6, we want to know, we have our function f. Where is it continuous but not differentiable? We've got to remember that differentiability implies continuity, but continuity does not imply differentiability. So we see f is continuous. It is not continuous at b, so we can rule that out. It is not continuous at d, so we can rule that out. Now we got to remember, we have a sharp point here. We got to remember that our functions are not differentiable at a sharp point. That's why the absolute value function is not differentiable at 0, because we have that sharp point at 0. So that is our answer choice A. Okay, now we're also talking about differentiability and continuity. So f is not differentiable at x equals 5. That is the opening statement on all of our answer choices. So we have to understand why it is not differentiable at x equals 5. Well, I'm going to do something here. Let's look at a graph of our piecewise function. If I can draw a straight line. And set x equals 5. All right, so we know from the top part of our piecewise function we've got y equals 2 for x less than 5. Now let's see what happens for our bottom portion when x equals 5. So when x equals 5, we're using the bottom portion, and that is 10 minus 4, and that equals 6, which is going to be way up here somewhere. So because these two portions are not equal when x equals 5, then our function is not differentiable because it's not continuous at 5. So answer choice A, we're not continuous at 5 because for the left side of our function, y is equal to 2, and then at 5, y is equal to 6, and it goes up from there. All right, now let's decipher what we've got going on here. We've got values of the differentiable functions f and g, and we also have their derivatives. And I wish this could have all fit on one line. So we've got h of x is equal to 2f of x plus 3 times 1 plus g of x. And we want to know what is h prime of 1. Now, the way I want to approach this, it should be h of x. The way I want to approach this is rewrite my h of x. I can go ahead and do my distributive property because all of these represent numbers. So I can write and say h of x is equal to 2f of x plus 2f of x g of x plus 3 plus 3 g of x. All right, now we want to know what is h prime of 1. Well, first of all, let's go ahead and see what is h prime of x. What is our derivative of h at x? And the derivative there is going to be 2 f prime of x. All right. Okay. Using our properties here, and we have a constant multiplied by that, so the derivative is just going to be the constant multiplied by the derivative. And now we can use our product rule. So that's 2 f prime of x g of x plus 2 f of x g prime of x. The derivative of that constant is going to be 0. And then we can say 3 times g prime of x. Now we're ready to substitute and say h prime of 1 is going to be 2 times f prime at 1 is negative 2 plus 2 times negative 2, and g at 1 is negative 3 plus 2 f of 1 is 3, g prime of 1 is 4, plus 3, and g prime of 1 again is 4. Now let's test our arithmetic skills. That is negative 4 plus 12 plus 24 plus 12. That is negative 4 plus 48 equals 44. Our answer is D. That was a fun one right there. All right, now number 9, we've got, okay, taking the derivative at this value of x, we're going to have to use our product rule. So again, I'm going to say this is f, this is g. We're looking at f prime g plus f g prime. So the derivative of sine is cosine. So cosine x plus, now that is sine x, negative sine x, giving us cosine squared x minus sine squared x. That is our, use my correct notation, that is y prime. Now we're looking for y prime at pi over 3, so pi over 3 minus sine squared now our cosine at pi over 3, this is one of the values that you need to know, so that is 1/2. So we have 1/2 squared minus sine at pi over 3, square root 3 over 2 squared. So that is, gives us 1/4 minus 3/4 equals a negative 2/4, which we know better as negative 1/2. And our number 10, we've got our good old quotient rule in effect once again. So once again, we've got f prime g minus fg prime divided by g squared. All right, so f prime is 1. So that gives us 1 times x squared plus 1 minus f g prime is 2x. All of that divided by x squared plus 1, that quantity squared. So let's go ahead and eliminate E and B. All right, now this gives us x squared plus 1 minus 2x squared minus 2x. All of that divided by x squared plus 1, that quantity squared. Now let's combine our like terms. X squared minus 2x squared gives us a negative x squared minus 2x plus 1 divided by x squared plus 1 squared. And that matches up with our answer choice C. C is our answer there. All right, now we're looking for the instantaneous rate of change at x equals 2 for that given function. Which means first we need to find what is the derivative of this function. So that's the way we need to interpret that, understand that. So taking the derivative, we have our quotient rule again. So f prime of x is going to equal f prime is 2x times g, x minus 1, minus f, g prime is 1, divided by x minus 1 squared. Now combining like terms, or no, doing distributive property first, we're going to get 2x squared minus 2x minus x squared plus 2 divided by x minus 1 squared. And I'll go ahead and combine like terms. This is going to be x squared minus 2x plus 2 divided by x minus 1 squared. And we want, what is f prime? What is our derivative at 2? So that is going to give us 2 squared minus 2 times 2 plus 2 divided by 2 minus 1 squared. And I'll just go, well, 2 squared, that's going to be 4 minus 4, 0. 2 divided by 1 squared is 1. So we have an instantaneous rate of change of 2. D is our correct answer there. All right, number 12. Okay, another one where we have to take the derivative and then evaluate it. F prime of x. This is a little bit more straightforward. We have 7 plus 1 divided by x. So f prime of 1, well, that's just 7 plus 1 divided by 1 equals 8. All right, number 13. It says a calculator is allowed, but really, we don't need a calculator for this. And as we look at this, we see we're not given any numbers. And we want to know which of the following has the greatest value. So f of a, well, we don't know what f of a is, but we do know this is a negative number. So f of a is going to equal, just say, negative n, some number n, but it's negative. F prime of a, Well, as we look at this here, f prime of a is the slope at a. So that's going to be some positive number. It's going to be some positive, we'll call that just some number d. F prime at c, well, if we look at c, that looks to be a turning point from increasing to decreasing. So it looks like our slope there is going to be pretty much flat. So that's going to equal 0. What about f of d minus f of c? Well, f of d is less than f of c. So that means that's also going to be some negative number. Let's call that negative p. So we know it's not going to be that negative number. It's not going to be that negative number. It's not going to be 0. So right now we're just seeing that we have a positive number here at a. What about f of b minus f of a divided by b minus a? Well, that is the slope between b and a. So that is that slope right there from b to a. And as we look at this here, it is kind of close, but this number is going to be less than d. This number, this arbitrary number d that we picked to represent the slope at a. So that tells us that the greatest value is our derivative at a, the slope of that curve at a. All right, now on this one, the graph crosses the x-axis at one point in that interval, and we want to know what is the slope of the graph at that point. All right, and we've got to use a calculator here. All right, well, first of all, let's understand crossing the x-axis. We want the slope where it crosses the x-axis. So we want e raised to the tangent x minus 2 to equal 0. That represents crossing the x-axis. And we know it's going to be in that interval. Let's go ahead and say we've got e raised to the tangent x equals 2. Now let's take the natural log of both sides. So tangent x equals natural log of 2, which means x is going to equal the inverse tangent of the natural log of 2. Okay, now I have my calculator up here. So x is equal to the inverse tangent of the natural log of 2. So putting it in radians mode. So 2 natural log of 2 there. Can't really see that. There's our natural log of 2. And we want the inverse tangent of that. And we'll call it 0.606. Now, that looks like a, but wait a minute. That's just the value of x when this function crosses the x-axis in that interval. Now, we need to look at the derivative, because it's asking for the slope of the graph at that point. So the derivative, we've got to take, well, e to the tangent x, and then we need to multiply it by the derivative of tangent x. So that's secant squared x e raised to the tangent x. And what we're looking for is y prime at 0.6061. Okay, so now follow along with what I'm going to do here. We want the secant at 0.6061. So let's go ahead and find, see, we've got that number already in here. So we want to take the cosine of that. So we take the cosine of that, then we square it, and then we say, well, I want the inverse of that. Since we're talking about secant is the inverse of cosine. So 1.48045. So let's write that down and keep that in mind. All right, get that squeezed in there. So now back to our calculator, let's look at tangent x. So now let's go ahead and clear this, and we need the tangent of 0.6061. 6061. I could have stored it, but I didn't feel like doing all that. We want the tangent of that. All right. And now we want e raised to that value. How am I going to do this here? Okay, here we go. Clear that. So we wanted the 6061. We wanted the tangent of that, still in radian mode. Tangent of that, okay. Now we want e raised to that. So we go to our second e, and we see it's 1.999, you know, all that there. Now, so let's go ahead and write this. We got times 1.999 something else. All right, so back to our calculator now. So that we're at that number. Now we want to multiply that by our 1.48045. And we get 2.9608, or, hey, that's very close to 2.961. And that is our correct answer. Let's make that look better. All right, number 15. We have f of x. We want to know what is the derivative at 4. And yes, that doesn't quite show up real good there. But anyway, we've got f prime of x is going to equal 1 divided by 2 square root x. And well, let's go ahead and say f of x equals x to the 1/2 plus 3x to the negative 1/2. So that's going to be minus 3 divided by 2x to the 3/2. All right, so our power rule tells us we've got negative 1/2 times 3, and then x to the negative 1/2 minus 1. Now we can substitute 4. And, oh, this was a no calculator question. Okay. 1 divided by 2. Well, go ahead, put f prime of 4. 1 divided by 2 times the square root of 4 minus 3 over 2 times 4 to the 3/2. And we can go ahead, I'll just put it over here. 4 to the 3/2 is equal to 4 to the 1/2 cubed. So that's 2 cubed. So now we've got 1 divided by 2 times 2 is 4. So 1/4 minus 3 divided by 2 times 8. That 4 to the 3/2 is equal to 8. So 1/4 minus 3/16 is equal to 4/16 minus 3/16, which equals 1/16. Our answer is A. All right, and our last one from the multiple choice, number 16. All right, this one was cool right here. So we want to find the equation of a curve that intersects at right angles every curve of this family right here. 1 over x plus k gives us k takes all real values. All right. So this forces you to think back to right angles. That means perpendicular. All right, let's look at what we have here. So for this family of curves, 1 divided by x plus k, call that x to the negative 1 plus k. So we need to find the slope of this family of curves at every point. So the slope at every point, y prime, is going to be negative x to the negative 2, and, well, that just goes to 0. That constant goes to 0. The derivative of that constant is 0. So that means y prime is equal to negative 1 divided by x squared. So now, right angles. That means, let's see, let's call this y1 prime. So the slope of y1 prime is negative 1 over x squared. That means the slope to anything perpendicular, all right, is going to equal the negative reciprocal, x squared. So which one of these is going to have a slope of x squared? And this is really bothering me right here. Okay. Better. So any perpendicular slope is going to have the negative reciprocal. And when we look at this, we want y prime to equal x squared, and we'll call that y2. And if we look at answer choice D, if y equals 1/3 x cubed, then that derivative is going to be equal to x squared. D is the correct answer. Okay, number 17, our free response. We want to approximate the value of the derivative at 4.5 using data from the table. And you cut it off here. Okay, and we want to show the computations that lead to the answer. Well, we've got to keep in mind that the derivative at this value is going to be approximated by the slope at that value. So if we want the slope at 4.5, we want to use values close to that. So we want to use this right here. So approximating from the secant line, we've got f of 4.5 minus f of 4 divided by 4.5 minus 4. So that's going to equal 3.193 divided by 2.5 minus 533 divided by 0.5 divided by 1/2. And that is equal to 0.660 divided by 1/2, 1.320. So on this one, this free response, you get the points for showing the difference quotient right here and using a good approximation. And again, the best approximation was to use this 4.5 and that 4. That one was worth 2 points if you showed all that. And I always like to box my answer no matter what. All right, now part B. We need to recognize this as the definition of the derivative, which is the slope of the tangent line. So if we interpret this as to say, is there a value of x between 0 and 5 such that the slope of the tangent line is 0? And we also need to give a reason for our answer. So the answer, yes. And our reasoning, or what is there a value? Yes, there is, and give a reason. So we need a reason, and we want to show our value. So we're saying that this limit statement is the definition of the tangent. Actually, let me do it this way. Let's do it the same Um, and I'll make this as concise as I can. Come on. Why aren't you letting me put my text in here? Okay, there. There we go. All right, the limit statement is the function has a horizontal so there is where the given limit is 0. All right, so that is the most concise, well, maybe not the most concise, but a pretty concise way of writing that answer. And we are showing our reasoning and showing that we recognize this limit statement as the definition of the tangent, and there is a tangent at x equals 0, or the tangent appears to be horizontal at x, did I say x equals 0? At x equals 2. All right, and then this also had a part C, so let's look at part C. All right, now on this one, so we have the following limits. Let's look at our graph of f, and we want the limit as h approaches 0 from the right, and we're talking about this point here of f of 5. Well, we have a straight line, so that limit there is talking about the slope of the tangent, and that slope, if we look here, is 1/4. So that means that limit equals that slope, which is 1/4. All right, now let's look at this next one, approaching from the left. Approaching from the left, and let's see if I can, no, that's, not quite there. But what we're looking at with this one here, and that's about as, oh, I had drawn this one in nice and good before. All right, but anyway, this one, if we look at what's going on here, that limit does not exist. That limit does not exist because we're approaching a 0 in the denominator. All right, so we can say our numerator, trying to draw in a slope here. All right, so our numerator, it seems to be approaching a slope of 3. Our numerator is going to 3, but our denominator is approaching 0. And part 3, well, the limit as h approaches 0, and again, we're looking at 5, that does not exist. And we can put one of two reasons here. Because the right and left limits, do not agree, or the fact that we have the jump discontinuity. Either one of those two reasons for why this third limit does not exist. Okay, last one. We have a function here, we have a table here, we have some words here. And according to the model F, we want to know the average rate of change of the temperature of the room over the time interval from 0 to 12 hours. Average rate of change. So we're looking at f of b minus f of a divided by b minus a. So from 0 to 12 hours, looking at f of 12 minus f of 0 divided by 12 minus 0. And this is going to be 65 minus 87 divided by 12, which is negative 22 twelfths, which we do want to simplify that to negative 11 sixths. And we want to put our units, degrees Fahrenheit per hour. All right, for part B, say we want to approximate f prime of 10. We want to approximate the instantaneous rate of change of the temperature in the room at 10 hours. So what we want to do here is use the fact that we can, the word approximate is our key word here. So we can approximate that tangent with the secant line. So we want to look at f of 12. That 10 is going to be somewhere in here. So we're looking at f of 12, or in this case, but f is g. I should have used g on the previous one. F of 12 minus f of 8 divided by 12 minus 8 is the same thing as saying we've got g of 12, since f of t is g of t. G of 12 minus g of 8, 12 minus 8 gives us 65 minus 70.5 divided by 4. So we have negative 5.5 divided by 4. And I really do not like that decimal in a fraction. So I want to go ahead and say that is negative 11/8 degrees Fahrenheit per hour. All right, part C, we want to know, is f continuous on from 0 to 24? Let's see here. I want to go back. In this problem, it said somewhere that it is continuous. Okay, yeah, G, all right, where it says G is differentiable. All right, so we know it's continuous from 0 to 12. And from 12 to 24, it's modeled by this polynomial. So our polynomials are going to be continuous. So what we need to see is, are we continuous where we switch from G of t to this second part down here in our piecewise function? All right, so this gives us the limit as t approaches 12 from the left of f of t equals f of 12, which equals g of 12. And that is equal to 65. Now we need to see what is the limit as t approaches 12 from the right of f of t, where that equals t squared. Let me see. T approaches 12 from the right. That limit of t squared divided by 8 minus 3t plus 83. Now using substitution, that gives us 12 squared divided by 8 minus 3 times 12 plus 83. And that equals 65. So is it continuous? Yes. How do we know that? Because the left-hand limit equals the right-hand limit. So it is continuous from 0 to 24. And last but not least, we want to know our instantaneous rate of change in the temperature of room at t equals 20 hours. So that means we've got f of t when t equals 20 hours. We're back to our t squared divided by 8 minus 3t plus 83. And our derivative with respect to t, we've got t divided by 4. Let's make that look a little better. T divided by 4 minus 3. All right, our power rule in effect. So now our derivative at 20 to give us our instantaneous rate of change is going to be 20 divided by 4 minus 3, which equals 5 minus 3, which equals 2. So we've got, to remember our units, 2 degrees Fahrenheit All right, try this one more time, do my F like this. 2 degrees Fahrenheit per hour. All right, box around that. And we're done.